designed and built a system for the nocturnal operation of a solar panel when the sun is out and grids are idle.
Starting off with the importance of some objectives here, we had safety as our most important objective. We really wanted to make sure this is something that we can put in homes and something we can put in industrial and commercial areas. Make sure that safety, would never ever be an issue. The efficiency of the system was also a very big priority, along with user friendliness, cost, and the size of the system. In terms of feasibility in the pre-design process, some of the aspects that we did put into consideration were our technical ability, our resources, our schedule, and along with some cultural responsibilities here. At the end of the day, we did see it as a project that was very feasible, and although it would be testing our abilities in some aspects, we did feel pretty confident in our ability to pull it off. Going on to the fan concept here, we had a nocturnal PV system that we wanted to create, and in that PV system we had the PV panel, the microcomputer, battery, the motor, and the blanket material, which was the original concept. Through the design process, we actually scrapped the blanket material, and we ended up creating a sort of LED sheet that we used alongside an actuator to power our system.
A block diagram is a visual representation of a system or process that uses blocks to represent different components or stages of a system. This provides a nice visual aid for people to help understand the system at a very basic level without going too much into the details. This level 0 block diagram shows a straightforward visualization of our system with 2 inputs, sensors, and DC power, and an additional operational block called Nocturnal System of Photovoltaics. The inputs are fed into the Nocturnal System of Photovoltaics, which performs the addition on the 2 inputs, and the result is output as LED lights. The level 1 block diagram will help explain how the inputs work to achieve the output. So here is our level 1 block diagram. As you can see, it is more complex looking than the level 0. That is because as blocks advance, the visualization gets more in depth with each level. Here, we open up the Nocturnal System of Photovoltaics block. Looking inside, we have the brains of our system, a microcontroller that takes the 2 inputs and converts them to output. The microcontroller makes the determination of what state our system needs to be in based upon the inputs and is responsible for driving several other pieces of outputs as seen. The microcontroller drives the motor drivers, system data, user data, and LED lights.
The way that our system works is depending on the reading from the photoresistor. In a daytime situation, the solar panel is getting energy from the sun, and during a nighttime situation, simulated by my hand covering the photoresistor, the panel will switch and then get energy from the LEDs in the system. And it does so by flipping the panel and then raising the actuator to better receive the power from the light. And then during daytime, again, once there's sun back out, the actuator drops, and then the panel once again flips to receive the energy from the sun.
As this is in essence an energy manipulating system, it is obviously important to talk about its energy efficiency. The LED circuit used to illuminate the PV panel had an instantaneous power of 79.40 watts as calculated by its voltage and current measurements. When illuminated by the LEDs, the PV panel generated a power of 2.66 watts as calculated from its open circuit voltage and short circuit current measurements. This gives us an energy efficiency of 3.45%, a staggering loss of energy of 96.65%. Knowing a priori that solar cell technology would render our system untenable, not to mention the second law of thermodynamics, which dictates the impossibility of a 100% efficient machine, these results are not at all surprising. Notwithstanding the results, the exploration of supplementary systems that can increase the hours of operation of existing industrial solar grids is a worthy one that may yield positive results in the years ahead.